Okay, good afternoon, class. This is the second part of our lecture in linear programming. So today we'll work on a minimization problem. So it says here, the campus dietitian of a state university was tasked to prepare a snack that their varsity players can use in their training programs. The dietitian intends to mix two separate products to make the snack. The following information has been obtained by the dietitian. So for the nutrients, we have product A, which contains 5 grams of carbohydrates, 6 grams of protein, 125 grams of calories, and the cost per gram is 10 pesos. And then we have product B, which contains 4 units of carbohydrates, 3 units of protein, and 50 units of calories. Now, based on the minimum requirements, the varsity player should be consuming at least 20 units of carbohydrates, at least 18 units of protein, and at most 450 units of calories. Okay. The cost per gram, okay, let us just correct this a bit. Okay, so this should be, okay. So for product A, it costs 13 per unit, and for product B, it costs 10. So we're asked to determine the optimal quantities of the two products for cost minimization. Okay. So to solve this linear programming problem, we start by formulating the LP model. Okay. So for the LP model, first we define the decision variable. We're using x of 1 to represent the amount of product A in grams. We are using x of 2 to represent the amount of product B in grams. Okay. Now, since all the details about x of 1 and x of 2 are already presented in this table, we don't need to perform this task because it has been done for us. So all the information about product A and product B are in the table. So all we need to do is to formulate the objective function and constraints. So as you can see, the problem is what is the cost per snack, and the objective is to determine the optimal quantities of the two products for cost minimization. So objective is to minimize cost. That's why in our objective function, the objective would be to look at the row pertaining to cost. So we have 13 per unit of product A and 10 per grams of product B. So the objective function would be to minimize C pertaining to cost, which is equal to 13x of 1 plus 10x of 2. Now, as to the constraints, we need to consider these these 3 rows pertaining to carbohydrate requirements, protein, and calorie requirements. So for carbohydrate requirements, so we're using x of 1 for product A, and we're using x of 2 for product B. So the constraint associated with the carbohydrate requirement is 5x of 1 plus 4x of 2. When we say at least, it means 20 and above. So the sign would be greater than equal to 20. For the protein requirements, we have 6x of 1 plus 3x of 2. Again, it says that the protein requirement is at least 18. So we have to use less than equal to 18 also. Now for the calorie requirements, we have 125x of 1 plus 50x of 2. But this time it says at most 450. So that means the maximum calorie intake of the varsity should be 450. So they should be taking calories or food with calories 450 and below. So this time we will use less than or equal to. Yan. So these are our explicit or structural constraints. Okay. So yeah. So these are just the explanation of how these things were formulated. So this is the complete LP model. So we have to add the inequality, I mean the non-negativity constraints x of 1 and x of 2 greater than equal to 0. So if you can recall in our last activity, the next step, the first step in using the graphical method in solving linear programming problems is to graph the constraints. And that is exactly your activity last time. So this time I will be using Excel, okay, to process this these things. Okay. Oops. Okay. Can you see, guys? Guys, kita ba? Okay.
Yes po.
Yes po.
So we will be creating columns for x1, for x2, and for rows for Z, for calories, for carbohydrates, okay, for protein requirements. So I'm using this column for my x1, and this will be for x2. Because we have to leave one blank row. Ay, sorry. Blank. Okay. And then for the Z, I'm just entering all the numerical coefficients. The Z meaning we are looking at the objective function. So what I will enter here are the numerical coefficient of our x1 and our x2. So this is going to be 15. And this is 10 for x of 2. Now I will use C1 to represent the first constraint, C2 for the second constraint, C3 for the third constraint. Okay, so the numerical coefficients are 5, 4. So the sign here is greater than equal to 20. I will enter the right-hand side in this column. Okay. For the second constraints, it's going to be 6, 3. Again, the sign is greater than equal to. Okay, so this is 18. Tama ba? Is it greater than? Yeah. Okay. And for C3, parang mali, guys. 125. Okay, less than equal to 450. Yeah. Okay. Now that we have all the numerical coefficients, so the next step would be to graph the constraints. So to graph the constraints, we need the intercepts. So starting with C1, so the intercepts are, starting with C1, okay. So X1, this is our X2. So setting X1 equal to, let's just start with the X, yes, guys?
4 po.
Okay, 4. 20 divided by 5 is 4. So we'll just use Excel to do the division for us. So 20. So if it's an x-intercept, that means ang x2 nun is 0. And then next, we set x1 equal to 0. So this time, yung 20 naman, we will divide by 4. So the x-intercept is 5. So we will do the same for C2. Okay. So, una, yung 18, we will divide by coefficient, the numerical coefficient of x of 1. The corresponding y value or x2 value is 0. And when we set x1 equal to 0, this time we will divide 18 by 3. Okay. Then for the last constraint, yung C3, okay. So, it's going to be 450 divided by 125. Okay. Susundan niyo ba, guys? Here we have equals 450 divided by 50. Kuha niyo, guys. This one is the x of 1 intercept. It's 40 for the first constraint. And the x of 2 intercept is 0.5. Okay. Now we'll ask Excel to prepare the graphs for us. So for the graph, what we will use is scatter plot. Okay. So scatter plot with straight lines and markers. Can you see, guys? What I chose, it's scatter plot with straight lines and markers. So here is the graph of the first equation. So ito yung 5x of 1 plus 4x of 2 equals 20. Okay, but we need to graph C2 and C3 as well. Okay, so right-click lang tayo and then choose select data. Okay, so what you see is actually series 1. So that's for the first constraints. We can edit this para alam natin kung ano siya. It's actually C1. Okay. Tapos we will add another line. So it's for C2. For C2, we have to enter the X values, meaning yung X of 1 values. Ang X of 1 values natin for C2 are 30. And our X of 2 values are 06. Okay. That's okay. So it's the orange line. Can you see, guys? So ito naman yung sa C2. But we have to add another one for C3. So click add ulit. And let's just call it C3. This time the X values are 0.6 and 0. And the Y pertaining to the X of 2 values are 0, 9. Okay, so now we have this gray line. Okay, nakita nyo, guys?
Opo.
Okay, so do we have the correct graphs? We have 4 and 5 for C1. Then we have 3 and 6 for C2. Then we have 3.6 and 9 for C3. So the next step is to identify where the shaded region should be. Okay, so now we do the testing of using a test point. Let's just use 0, 0 as our test point. Okay, so if you use 0, 0 as our test point, okay, this is going to be 0 plus 4 times 0. So that means the right-hand side will be 0, diba? So ang tanong, is 0 greater than 20? Is that a correct statement?
False po.
False, diba? So test point, 0, 0, lalabas na false. Kasi 0 is not greater than 20. So false tayo. Okay. What about sa second? 0 times 6 is 3 times 0. That's going to be 0. Is 0 greater than 18?
False po.
False ulit. So that means 0, 0 is not part of the graph. What about for the third constraints? Again, using the same point. 0 times 125 plus 50 times 0. So that's going to be 0. Is 0 less than 450?
True po.
Okay, so this time, dun sa third line, yung 0, 0 is part of the graph. So considering the result of the test point, okay, again, the first graph is the blue line and ang result false. So ibig sabihin, 0, 0 is not part of the graph, diba? So ang graph niya yung taas ng blue line. So we will put an X mark on all areas below. Okay, we will put an X mark on all areas below the blue line. So ito, X na to, kasi nasa baba siya ng blue line. This is also X, this is also X. Okay, now yung sa second, yung C2, ito naman yung orange line, again, ang result false. So that means 0, 0 is not part of the graph. So we will put an X mark on all areas below the orange line. Ito, may X na. So hindi na natin kailangan lagyan ng X ulit. Itong area na to, this should also have an X mark, because it's an area below the orange line. So the line representing the second equation. Now for the third equation, ito naman yun. So this time, ang sagot true. So that means 0, 0 is part of the graph. Diba? So if 0, 0 is part of the graph, that means ang X mark natin, yung all areas above. Okay, yung kabila, the gray line. So it's going to be an X mark for this big area over here. Tsaka itong small na to. Eh may X na. So okay na yon. So the only area in the graph which do not have an X mark is this part. So lagyan natin siya ng ano. Okay. So ang walang X, ito. Yan. Ayan. Itong point na to. Yan. So yan yung ating feasible region. Okay, so this is going to be our feasible region. So ito na siya. Gets niyo ba, guys? So ang next task is to identify what are the coordinates of the feasible region. So some of the coordinates are very apparent in the graph. Okay, so we can easily identify two, and these are 0, 6, and 0, 9. But this one is the intersection of the blue and the orange line, meaning first and second. And this point is the intersection of the blue and the gray line. Ibig sabihin, first and third. So yun yung next task. Now we can actually use our calculator to do the computation for us, or we can solve it analytically. Okay? Anong gusto nyo, guys? Solve natin analytically kasi parang hindi kita masyado kung ano yung intersection. But for those who have calculators, you can easily use your calculator to compute the intersection for you. Is there anyone who has a calculator? Would you want us to compute the intersection using calculator? Okay, so again, this point, okay, is the intersection of the blue and the orange. So what we need to compute are the intersection of C1 and C2. Okay, so for C1 and C2, we can use matrix, pero mas sanay kayo sa elimination. So this is for C1 and C2. We want the numerical coefficient to be the same, either for x1 or x2 in order to use the elimination method. So if we want to eliminate x of 1, then this should have the same numerical coefficient. Considering that we have 5 and 6, that means we will be multiplying this by 5. I mean by 6, and this one by 5. So if we multiply the first equation by 6, we will have, okay, 30 x of 1 plus 6 times 4 is 24. X of 2 equals 20 times 6 is 120. Now, yung C2, we will multiply by 5. So that's 6 times 5. So that's going to be 30 x of 1 plus 5 times 3. So that's 15 x of 2 equals 18 times 5, 90. So equals 90. So subtract the resulting equations. This will cancel out. 24 minus 15 is 9, x of 2. And 120 minus 90 is 30. So if we divide both sides by 9, we will have x of 2 equals 10 over 3. Okay, so that's our x of 2. Now, to get x of 1, we can substitute x of 2 equals 10 over 3 in the second equation. So that's going to be 6x of 1 plus 3 times 10 over 3 equals 18. This will cancel out. So 10 transposed to the other side, that's going to be minus 10. So 18 minus 10 is 8. So we have 6x of 1 equals 8. Dividing both sides by 6 will give us x1 equals 8 over 6 or 4 over 3. So this point here is 4 over 3, 10 over 3. Clear ba, guys? So ito naman, this one is the intersection of the third line, the gray and the blue. So that would be 5x1 plus 4x2 equals 20, and 125x1 plus 50x of 2 equals 450. Okay. So times natin to ng, okay. Wait lang, guys. Ano na lang. In the interest of time, can I just, can I leave that to you and I'll do the computations in my calculator? Okay, so the coefficients are 5, 4, and 20. And then we have 125, 50, and 450. Okay. So the intersection are So this is actually, so for verification lang guys, our x of 1 is 16 over 5. So this is 16 over 5 and our y is 1. Actually, clear naman nga na 1 pala, no? Clear yung 1 natin for x2. So if we have 1 for x2, so if we substitute 1 here, so magiging 4, di ba? Okay, so 4, pag nilipat mo sa kabila, that's going to be 16 over 5. So will it happen also in C3? If this is 1, so tatranspose mo yung 50 sa kabila, then you'll have 400. And 400 over 125 is ganun nga din. So 16 over 5. So the intersection really is 16 over 5. So once you have identified all the vertices, the next step would be to substitute the vertices of the feasible region in the objective function. Okay? So the points are, okay, so let's just plug in the x1 and x2 and the corresponding value of c. I will just enter all the coordinates. We have, first we have 0, 9, and then we have 0, 6, and then we have 4 over 3, 10 over 3. Okay, and then we have 16 over 5, 1. These are the vertices. Okay. If you want to express that in fraction, okay lang naman. Gawin natin siyang fraction. Yan. So 4 over 3 is 1 and 1/3, diba? So now let's compute for the z. The objective function is 13x1 plus 10x2. So equals where x1 is times 13, diba? 13 and 10. So times 13 plus 10 times x of 2. So ibig sabihin at 0, 9, our z is 90. At 0, 6, it's 60. At 1 and 1/3, 3 and 1/3, it's 50.67. And at 3 and 1/5, it's 51.6. Okay? So the objective is maximize or minimize? Minimize. So that means from among these results, we will choose the point that gave us the lowest value. And that's 1 and 1/3, 3 and 1/3. Okay? So therefore, our solution is, okay, so going back to the problem. Okay. There's a summary of that, of the graph. Okay. Yun din naman yun. Okay, again, 50.67. So since 4/3, 10/3 is the point that gave us the lowest value, therefore the solution is the campus dietitian should prepare a snack composed of 4/3 grams of product A and 10 over 3 grams of product B. This snack would cost 50.67. Okay? Question, guys?